Today's topic is caudal neurosecretory system in fish. We will talk about caudal neurosecretory system in fish. Fishes, as you know, have are vertebrates who have spinal cord. So, what is the caudal neurosecretory system? It's got a name, and the name of it is neurophysis. So, most fishes, they possess a europhysis. What is a europhysis? It is a neural secretory gland very similar in form to the posterior pituitary, but located in the tail and associated with the spinal cord. So, like in the anterior end, you have epiphysis. This is the pineal gland. You have the hypophysis, pituitary. At the caudal end, you have the europhysis, and the form is similar to that of hypophysis. So they are basically nerve endings, neurosecretory cells, and they release hormones known as neurotensins. Four kinds have been identified. These are neurotensin 1, 2, 3 and 4. It may be that all of them may not be present in one fish, but 1 and 2 are generally present in all of them. And their secretion is controlled by the central nervous system. Secretion of neurotensins controlled by central nervous system. So having a look, you can see you have the pineal or the epiphysis, then you have the pituitary, and then the spinal cord goes straight on to and ends in the neurophysis. More clearly, epiphysis or pineal gland located on the brain. Then you have the hypophysis or pituitary gland, and that goes and to the end, and this is the europhysis or caudal neurosecretory tissues. Now, if you look at the picture of a europhysis, you will see that on the spinal cord, several neurosecretory cells they originate. These neurosecretory cells, which you see, they originate here, and all in the europhysis, which is this basically all the nerve endings are present. All the nerve endings are present, and blood vessels are present. So all the hormones are released here in this region. So the europhysis, it is a neurosecretory organ found on the ventral aspect of the distal end of the spinal cord. These bodies, so the neurons are unmyelinated axons, and they terminate on a capillary wall in the europhysis. Function unknown, although neurotensins are secreted. We will see what is the function of these neurotensins. So most fishes possess europhysis, and it is similar in form to the posterior pituitary, but it is located in the tail and it is associated with the spinal cord. The europhysis consists of neurosecretory cells. Now, if you look at the diagram of the spinal cord in the tail region, you will see that Dahlgren cells are present. They are these green cells. From their nerve endings, they end in the europhysis, and these are all fluorescent microscopy, and these are cross sections. So it was first reported by this caudal neurosecretory system was first reported by Dahlgren in 1914 in teleost and elasmobranchs in bony fishes and in sharks. The caudal neurosecretory system is defined in teleost as a complex of secretory neurons. And those are the Dahlgren cells in the caudal spinal cord and leading to a tract to a neurohemal tissue organized as a typical neurosecretory storage release organ. So basically, the neurosecretory hormones are being released over here. So in homologs also there are urotensin homologs are found in vertebrates. So basically the roles in homeostatic roles in osmoregulation and reproduction. These hormones have been implicated. So in the teleos, the urophysis is a distinct, easily recognizable lobate structure of variable external form. So the hormones of the urophysis are called urotensins, and four kinds of have been identified: 1, 2, 3, and 4. Now look at the function of urotensin 1. It increases the blood pressure of fish, but it is less potent than of urotensin 2. Urotensin 2, it is involved in the contraction of smooth muscles such as urinary bladder, causing a marked increase in blood pressure and enhanced urine flow. Then you have the urotensin 3. It induces the sodium intake across gills in the osmoregulation of goldfish. So, urotensin 3 is involved in osmoregulation. Urotensin 4, it shows an activity like ADH, antidiuretic hormone or vasopressin of vertebrates. So, the most primitive organization of the caudal neurosecretory system is met within Squalus acanthius, Rhea betus, Rhea radiata, in which the terminals are situated within the nervous tissue, immediately under the meninx. This is a characteristic of the early stage of development of the primitive urophysis. A more advanced form occurs in torpedo, where the neurosecretory processes enter the meninx of the ventromedial part of the spinal cord. Thank you.